Hi everyone, we've now worked out how to find some missing sides on right angled triangles, and now we're going to see what happens when we're given some sides but we don't know the angles. So my question for you today is, if we've got a little bird sitting on the ground and it's about to fly up to the very top of the tree, what angle is it going to fly on to land right at the top of the tree? Now if we know that the bird is 7 metres, now when we say the base of the tree, I'm going to make that point there. And the height of the tree itself is 5 metres, then hopefully you can see our nice right angled triangle in there. And what we're looking for is this angle in here. We're trying to find theta. That's what we've talked about, using our Greek letters for our angles. So what angle is the bird flying on? Well, as with our other questions, the first thing we have to do is to label our different sides. So for the angle that we're looking at, yes, we've got the hypotenuse, but that's not going to help us in this question. The sides we know about are this one here, which is the adjacent, and this one here, which is the opposite. So again, we're going to go and use, I'll write it down here today, our SOHCAHTOA. Now I've written that every lesson, and you should be writing that lots as well, that word. You'll never ever forget how to spell that one. O and A are together here with the big T. So this is a tan question. So we're going to start by writing tan of theta. We don't know what that angle is yet. That's what we're trying to find. Is equal to, well, we want the opposite over the adjacent. The opposite is 5 and the adjacent is 7. So how are we going to solve something like that? Well, on your calculator you'll notice that above the little buttons that say sine, cos and tan, you'll see a sine with a little -1 at the top, and a tan with a little -1, and a cos with a little -1. So we're going to use those buttons on the calculator. You'll probably have to press a button shift and then tan to get this. So what we want to calculate, we're going to say that theta is going to be equal to tan to the -1, 5/7. Now you will probably on your calculator have to put that in as a fraction, or you may have to put brackets around it. So just fiddle around on your calculator until you can get the following answer. You should end up with theta equals 35.54 degrees, because we're finding an angle. So even though our distances here are in metres, our answer to this question, because we're looking for the size of an angle, is going to be in degrees. So you won't be putting metres or centimetres or anything like that in these questions. So 35.54 degrees, and often the textbooks will say give your answer to the nearest degree. So we're just going to round this up to the nearest whole number. So we're going to say theta is equal to 36 degrees to the nearest degree. So make sure that you can get your calculator to give you that answer. So some hints are to make sure that your calculator is still in degree mode, so it'll have a deg or a D somewhere on the screen, and you may have had to put that into brackets to get the correct answer. Okay, so that bird flew on an angle of 36 degrees. Let's go through and try these next questions. You can pause, write this down, have a go at these by yourself, that's completely up to you. Let's say in this next question we want to find the size of this angle here. So we're going to write down which sides we've got. Well, this time we know the opposite and we know the hypotenuse. So looking at here, where are O and H together? Here they are here with our big S. So this is going to be a sine question. It's a sine question. So I'm going to write sine of theta is equal to the opposite over the hypotenuse. We know that order is important. So it's going to be 14/32. We're going to have theta equals sine to the -1 of 14/32. And again, you may need to put that into brackets in your calculator. It just depends what calculator you've got. And you'll end up with 25.94 degrees, or more simply 26 degrees, rounding it off to the nearest degree. So again, our answer is in angles, degrees as well. I think you can have a go at the next one by yourself. If I tell you that this is the angle we're looking for, so pause and have a try of that one. When you're ready, come back. So in this question here, from this angle, we've been given the hypotenuse and the adjacent. So it's no surprise that this question with the A and the H is going to be a cos question. So this is a cos question. Cos of theta, the angle we want to find, is equal to 10 over 15, the adjacent over the hypotenuse. So theta equals cos to the minus 1 of 10 over 15. When you put that into your calculator, you should get 48.19, which rounds off to 48 degrees to the nearest degree. That's the basics of finding an angle. Now there's some different things we can do with angles and different ways we can display them. So there's a bonus video coming up, you can go to that if you want to, but this is everything you need to know about the basics of finding an angle in a right angle triangle. Thanks for listening.